In this lesson, we're proving parallelograms in a coordinate plane using ordered pairs. So let's get into the lesson. So we have three methods here that we're going to use to prove parallelograms in a coordinate grid. Method 1, we can prove that both pairs of opposite sides are congruent. So therefore, if AB, line AB, is congruent to line or segment CD, and segment DA is congruent to BC, then ABCD is a parallelogram. And we could use the distance formula here to actually find the length of each side there using the ordered pairs. Method 2, we can prove both pairs of opposite sides are parallel. So if AB is parallel to CD and AD is also parallel to BC, so if those two sides or opposite sides are parallel, then ABCD is a parallelogram. We can use the slope formula to find the slope of each side there, and that is the slope formula. In method 3, we can prove one pair of opposite sides are congruent and parallel. So if AB is congruent to CD and AB is also parallel to CD, then ABCD is a parallelogram. And we could use both the slope and the distance formula to prove that. All right, so now let's try some examples. I have one example of each that I'm going to do with you, and three of each, or one of each that I'm going to have you try on your own. So the first one here, method 1, I'm going to use the distance formula to see whether or not these ordered pairs would create a parallelogram, and I have the distance formula here. So I'm going to find the length of each side. So AB would be first. So if I label x1, y1, x2, y2, plugging that into the distance formula, I'm going to have 1 plus 7 squared, because I have minus a negative, so that would be a plus, and plus 2 minus 4 squared. Simplifying that, 1 plus 7 is 8. 8 squared will give me 64. 2 minus 4 is negative 2, but negative 2 squared will give me 4. And I'm left with the square root of 68. Now, since I want to know the exact length, I'm going to use simplest radical form. So I can find two factors of 68, and one should be a perfect square. My two factors are 4 and 17. All right, and I could take the square root of 4, which is 2, so I can bring that on the outside of my radical, leave my imperfect square underneath the radical. So the first length of AB is 2 square root of 17. Next, BC, labeling now x1, y1, x2, y2. Plugging that in, 9 minus 1 squared plus negative 8 minus 2 squared. Simplifying, 9 minus 1 is 8. 8 squared is 64. Negative 8 minus 2 is negative 10. Negative 10 squared is 100. So I'm left with the square root of 164. Again, simplest radical form. My two factors would be 4 and 41. So that's my highest perfect square. 4 times 41 gives me 164. I'm going to take the square root of 4 because that is my perfect square. And I leave the 41 under the radical. All right, next, CD. Plugging it in. And let me just use a different color to label. CD, x1, y1, x2, y2. Plugging that in. 1 minus 9 squared plus negative 6 plus 8 squared. Simplifying, 1 minus 9 is negative 8. Negative 8 squared is 64. Negative 8 plus 8 is 2, and 2 squared is 4. So I can see here that it's going to be the same as AB, right? Because I get square root of 68 And that will give me 2 square root of 17 because that is the same as a CD. And last, I'm going to use A and D. So I have to use all 4. So AD. So I'm going to label this X1, Y1. A lot of X1, Y1s here. And X2, Y2. So I kind of changed the color to let you know I'm using these two. So, or DA rather. So actually, I'm going to switch this. I'm using DA since I went. So X1, Y1, X2, Y2. There we go. But if you flip them, you will get the same thing. All right, so 1 plus 7 squared, because I have minus a negative, and negative 6 minus 4 squared. 64 plus 100. If you know how to use a distance formula, you could fast forward through this if you understand how to use it to see how we get the answers there. And I get 164, and I could break that up. My two factors are 4 and 41, but I could see that it's the same as BC. All right, so I noticed that AB and CD are the same length, and BC and DA are the same length. Therefore, AB and CD are both congruent, and BC and DA are congruent. Therefore, yes, ABCD is a parallelogram. So try this problem on your own using the distance formula to see if this is a parallelogram. So go ahead and pause the video and try this problem on your own. So hopefully you saw that this is not a parallelogram. So go ahead and check your work. Hopefully you got it correct. Let's move on to method 2. We want to use the slope formula to determine if these ordered pairs would create a parallelogram. So I have the slope formula right here. And first I'm going to find the slope of WX. So I'm going to label my ordered pairs X1, Y1, and X2, Y2, and just plug it in. So M equals, so Y2 minus Y1 would be negative 6 plus 4, because I have that minus negative, so that's a plus. And then 1 plus 7, so same thing, I have a double negative. Reduces to negative 2, or simplifies to negative 2 over 8, and reduces to negative 1/4. Alright, so next, XY. So X1, Y1, X2, Y2. Same thing, plugging it in. That would be negative 13 plus 6 over 5 minus 1. Simplifying, I get negative 7 over 4. Can't reduce that anymore. Next, I have YZ. And then I'm going to label this as well. X1, Y1, X2, Y2. So that would be M is equal to negative 12 plus 13 over 1 minus 5. Simplifying, I get negative 1/4. Because 1 minus 5 is negative 4. So negative 1/4. And then last I want to do ZW. So change the color here. X1, Y1, and X2, Y2. And so that would be M equals negative 12 plus 4. I have that double negative. And 1 plus 7 is equal to negative 8 over 8. That reduces to negative 1. So as I can see here, I do have opposite sides that are parallel here. So these two are parallel. However, these two are not. All right. So this figure would not be a parallelogram. So although WX is parallel to YZ, and this is just a makeshift parallelogram, this is not drawn to scale from a coordinate grid, but just to give you an idea. So we only have one pair of parallel sides, and so no, this figure would not be a parallelogram. Alright, so I would like for you to try this problem on your own. Use method 2 with the slope formula to see if these ordered pairs will make a parallelogram. So go ahead and pause and try. These ordered pairs do create a parallelogram. Hopefully you got it correct. If not, go ahead and pause the video and analyze the work here. For our last method here, we can use the slope and the distance formula to determine if these ordered pairs will make a parallelogram. And we only need to prove that one pair of sides is both congruent and parallel. So I'm going to use sides JK and LM. So let's start by finding the length of JK using the distance formula. I have it right here. Let's label it x1, y1, x2, y2. Plugging it into the distance formula. I get negative 5 plus 9 squared. Again, that double negative makes it a plus. And then plus 1 plus 2. Again, double negative. That minus a negative gives me a plus here. Alright, negative 5 plus 9 is 4. 4 squared is 16. 1 plus 2 is 3. 3 squared is 9. I get the square root of 25. And I get 5 for the length here. I'm going kind of fast because I hope that at this point you know how to use the distance formula. So if you pretty much understand the distance formula, you can kind of fast forward and pause and look at my work here. But if you still need a refresher on the distance formula, just keep watching. Alright, so I'm going to label finding LM, x1, y1, x2, y2. Plugging it in, I get negative 3 minus 1 squared plus negative 7 plus 4 squared. Again, negative 3 minus 1 is 16. I'm sorry, 4. 4 squared is 16. Negative 7 plus 4 is negative 3. Negative 3 squared will give me 9. So again, we can see here that I get the square root of 25 and I have a length of 5 for both of these. So it's not enough to just show that they have the same length. I'm going to use the same sides to show that, or to see if they are also parallel. So JK, using that again. And I already have it labeled x1, y1, x2, y2. So I'm using the distance, the midpoint formula. That's going to be M is equal to 1 plus 2. All right, yeah, 1 plus 2, because I have that double negative, and negative 5 plus 9, again, that double negative. And that would be 3 over 1 plus 2 is 3, negative 5 plus 9 is 4. So I get 3/4. And then last, LM. That would be slope is equal to 7 plus 4, or negative 7 plus 4, over negative 3 minus 1. That leaves me with negative 3 over negative 4, and that reduces to positive 3/4. So the same pair of sides is both the same length, and they are both parallel. So JK is congruent to LM. JK is also parallel to LM, and this is just a makeshift parallelogram so you can see a visual. So we can conclude that yes, JKLM is a parallelogram. So we finally reached our last problem. I would like for you to pause the video and try this problem on your own using the distance and the slope formula to determine if these ordered pairs would make a parallelogram. So these ordered pairs will not create a parallelogram. Hopefully you got it correct, but if not, go ahead and just pause the video and analyze the work a little bit here. We've reached the end of our lesson. I want to thank you for learning with me. So related videos are properties of rectangles as well as area of regular polygons. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.